In this video, we're going to talk about how to describe key features of the sine and cosine graphs. So remember, we talked about the unit circle in the last lesson, and we said that you could figure out the values of cosine, sine, and tangent using the unit circle. So sometimes you'll see the question phrased like this. It'll say, what coordinate is associated with an angle 11 pi over 6? And when they're talking about coordinates like this, what they're asking you to do is to go to the unit circle and just read the xy coordinates that are there. So to solve this problem, you're just going to go to your unit circle and find 11 pi over 6, and then you can see that the coordinates are the square root of 3 over 2 and then negative 1/2. So that's the coordinate associated with 11 pi over 6. So what we can do is we can read those values of sine, okay, and then make those y, and then read the values of the angles and make those x. If we do that and then we graph, we can create the graph of the sine function, right? If we're just reading off the sine values. And so what this is a trigonometric function where the input is x and the output is y. So in this video, we're going to talk about the graphs of the sine and cosine functions. So remember the last video, we talked about the unit circle and we talked about how you can find the sine, cosine, and tangent measures of important angles using the unit circle. So sometimes you'll see the question phrased like this. It'll say what coordinate is associated with an angle 11 pi over 6. And when you see this kind of problem and it's asking for the coordinate, what it's wanting you to do is go to the unit circle and find 11 pi over 6. And then all you have to do is just write down the x and y coordinates that are listed there. So the answer to this would be square root of 3 over 2 and negative 1/2. So what we can do now is we can create graphs of trig functions using these values. So if we create an xy table, right, just like we're going to go graph, and then if we say x is all of the angle measures, okay, these are the angles, and then we write down all the sine values we get from our unit circle, we can create the graph of y equals sine x, which is a trig function. We can do the same thing with cosine, right? So if we say the input is always the angle and the output is the cosine values, then we can create a graph of the cosine function. So here in Desmos, I've created the graph of y equals sine x, so you can see what it looks like. Notice that it looks like a wave, and notice that it has like this repeating pattern, right? The shape of the graph just kind of keeps repeating itself. Here's the graph of y equals cosine of x from Desmos, and notice that it has a similar wave-like pattern. So it has a wave-like pattern because sine and cosine x are what's called periodic functions. And what it means by periodic function is the shape of the graph will repeat after 2 pi. So let me show you what that means. So you can see here from 0 to 2 pi, I have one entire cycle of my graph. It starts here at 1, then it goes down, and then it comes right back up, and then it just starts all over again. Okay, so over another interval of 2 pi, it'll keep repeating that same shape. Okay, and you see that happens like throughout this graph. Every 2 pi, it just keeps repeating. So that's why the shape of the graph is called a periodic function. So here are some characteristics of trig functions. They're periodic functions with a period of 2 pi. The domain of each function will be negative infinity to infinity, so all x values, and the range will go from negative 1 to positive 1. Y equals sine x is symmetric about the origin, and y equals cosine of x is symmetric about the y-axis. So here are some characteristics of the graph. So if we look at sine x, notice that we have maxima. Anywhere you see like a hill on your graph, the graph will have a maximum value, right? So it has maxima at negative 3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2, and it just keeps repeating. So also you can see this function has minima at any points where it looks like kind of like you have a valley in the graph, right? So you can see here at negative 5 pi over 2, negative pi over 2, 3 pi over 2, etc. It has minima values of negative 1. So we also have general form of the trig equations. We have y equals a sine bx minus c plus d, and we have y equals a cosine bx minus c plus d. So just like when we talked about transformations with other functions, the values of a, b, c, and d will transform trig functions. But we have a little bit different vocabulary when we're talking about trig functions because the shapes of the graphs are a little bit different. So a will tell you the amplitude of the function, okay? And what the amplitude of the function is half the vertical distance from the maximum to the minimum. So we have this like wave-like shape to our graph, right? So to find the amplitude, we're going to take the distance from here to the bottom, right? So like this distance right here, and then cut that in half, okay? So that's going to be our amplitude. So it's kind of like the height of our graph. 2 pi over b, right? B is this coefficient of x, will tell us the period of the function. So the interval over which the function completes one full cycle. So remember, for like y equals sine x, this period is 2 pi because the coefficient of b is just 1. C over b will tell us the phase shift, and that's kind of like a horizontal shift. D will tell us the vertical shift. So you can see some of this is similar to what we learned about with transformations of other functions, and then some things are a little bit different because we're talking about trig functions. So when we graph trig functions in Desmos, you're going to want to adjust your scale so your graph will look correct. So usually these are graphed in radians. So what you'll do is you'll go over here to this wrench in graph settings, and then you go down here. I like to turn the minor grid lines off, but that's just a matter of personal preference. And then here in step, if you start typing pi, it'll automatically turn into the pi symbol. Okay, so you just type pi and the pi sign shows up. And then we do pi over 2. And then the y-axis, I like to rescale it so that it's 1. You don't have to do that, but I just like to do it. Also, you want to make sure that down here, this is in radians because usually we graph these in radians. Okay, so here's the first question. It says, for which values in the interval 0 to 6 pi is y equals cosine theta equal to -1? So when I'm graphing these in Desmos, instead of using theta, I just go ahead and call it x. Okay, so y equals cosine of x. And we're looking at the interval from 0 to 6 pi. Okay, so I'm not looking at the entire graph. I'm just looking from 0 to 6 pi. If you want to draw in the boundary line so you know which section you're looking at, you can do that. Okay, so you can just do x equals 6 pi, and then if you draw a little line there, it'll just kind of help you remember where you're looking. So we want to look everywhere this graph equals -1, right? So here it equals -1, right? Here it equals -1. Here it equals -1. So we would say that at pi, 3 pi, and 5 pi, it's equal to -1. Notice that these values have a difference of 2 pi, and the reason for that is because cosine theta has a period of 2 pi. Okay, next question. So how many points in the interval -2 pi to 2 pi is sine of theta equal to 1? So once again, I'm going to graph y equals sine of x. Okay, and we're going to look at values in the interval, different interval this time. So we're going -2 pi. Okay, there's -2 pi, and then I'm going to 2 pi. Okay, so -2 pi to 2 pi. Let me zoom in a little so you can see. No, that's too much zooming. Okay, zoom out. Oops. Okay, there we go. Okay, so -2 pi to 2 pi, and we're looking for where it's equal to 1. Okay, so here I can see it's equal to 1, right? And then here's another place it's equal to 1. And then this is past 2 pi, so I don't want that point. Okay, so it says that how many points in the interval -2 pi to 2 pi is sine of theta equal to 1? It's at 2 points, right? We know what those points are. We know that at -3 pi over 2 and pi over 2, it's equal to 1. Okay, so here it says which equation is shown graphed below. So this is actually a transformations question, but I don't want to get into too many details on transformations. I just want to show you how you can solve this using Desmos. If you want to get into more details, I have a linked textbook chapter that you can read and get more details about it. The best way to do this problem, honestly, is to go ahead and use Desmos to help you out. So we type y equals cosine x minus pi. Okay, and I want to check if the graph I get is matching the one that I have in this image. Okay, so notice the one. How do you know if it matches? You want to see if it has the same points. So you see it as a y-intercept of -1, looks the same. It equals 0 at pi over 2. That part looks the same. It equals 0 at negative pi over 2, looks the same. It has maxima at pi, negative pi. It looks like it's the same. So A is going to be the correct answer choice.